Hello viewers, for today's video we're taking a look at FlightGear, and more precisely a program I wrote up for it a while back called FGFSCopilot. It's a flight automation program, and it does quite a lot more than what you would get from an FMC, but it's also a bit limited because it's designed to be universal. So you see here for today we have the DHC2 Beaver. Well, yeah. And this is an old model, so looks like the lighting might be a little bit funky on it. So a JFS Copilot only works if the aircraft if it has a custom autopilot. It has to be have a similar property tree structure to the generic autopilot, or the airplane needs to not have a custom autopilot so that it instead uses the generic autopilot. So yeah. Alright, give me a second here. I'm going to get the engine started so that we can get things set up here with FGFSCopilot. Alright, so we have the engine running. We are ready to get started putting the data into FGFSCopilot. So you may think it's strange, why would I use some kind of flight automation like this in a piston powered aircraft? And well, I guess the reason is because I can. So yeah, that's what we're doing here. Give me 1 second. Okay, so what we're gonna do, let's see if I remember the parameters for this plane that I haven't used in about a decade. Rotate, that's probably going to be about 40 knots. Cruise is going to be 100. Mach we don't have to worry about. Approach, looks like 60 miles an hour. In knots, that's going to be a lower number. Let's say 55. I think that sounds about right. The flight we're doing, the first flight I should say that we're doing, one second. So we're going westbound about 40, southwest about 40 miles. So I'm going to say cruise at 4,000 feet. Flying power, about 2,000 RPM should be good. Okay. So we are at Tango 78. And let me double check the runway. 16. Okay, there we go. Runway 16. Going to Ellington Field. 1 second here. Ellington Field. 17 right. I have a chart up I'm looking at. You can't see. Runway heading is going to be 174. Touchdown zone elevation is going to be, why can't I find it? 32. Okay. Alright. So now I just have to hit the start button. It's going to create the route, right? So let me show you real fast. Route manager is empty. So I'm going to hit the start button. And we'll just go with the default for mod. It doesn't matter. Okay, now we're taking off. I just need to use rudder to guide it down the runway. I forgot to set my altimeter, so I'll do that once we start climbing. Okay, we should... Yep. So it's... Sorry for bumping the mic there. So yeah, it's going to drop the throttle a little bit, but we're climbing out. We should be climbing. Something is wrong, I think. Come on. Alright, we are going to rectify this by increasing the rotate speed, which gives me a new value for Vy, and then I'll have enough lift Come on. So evidently I had the wrong, some bad data, bad numbers that I tried to use in here. Okay, now we just need to wait till 500 AGL, and then the fun stuff's going to happen. We could see it put in an IAP waypoint that it created, and then I'm going to be flying down that runway heading roughly for 4.9 miles. So I'm just going to hit activate, and now when it gets to the next phase, when it gets to actual climb, which reminds me I need to set my altimeter. 29 or 9 or 2. Okay, the altimeter is set fine. Okay. Just double check that. Yep. Alright, so it's going to take some time to build altitude from here, climbing like this. So, clearly I don't think I had this set up with tail draggers in mind. I don't know. We're gonna run with this and see what happens. I believe I need 500 AGL before I can turn or anything, before it goes into the next phase. So we're just going to leave it go. I believe I am not actually flying to quite toward where I want to go right now. Oh yeah, I am, okay. So I just happen to be flying in the correct direction, vaguely. So, at least I have that going for me. So we are in the climb out phase. We're just here. We just hold 10 degrees nose up, wings level, retract gear and flaps. As you've already seen, this plane does not have retractable landing gear. And then it also has a speed mode for that. It's in the VY speed mode right now. Which, in this case, we're just estimating or guessing the speed, the best climb speed based on the rotation speed. So we're holding 70 knots because I punched in a rotate speed of 50. And now we've shifted from climb out to climb. So you're going to notice we are turning en route, and we are using vertical speed as guidance. Now it starts with the actual vertical speed setting that I used, and I don't like this because we're climbing at a cruise power setting. Let me make that 2300 and see how that works. I'm going to hit the start button again. So unfortunately, it's going to take a little while for FGFSCopilot to give me more climb rate, but 100 feet per minute is not really acceptable. Okay. No errors, so it's good. So every time it iterates, it's going to increase the climb rate by 25 feet per minute until it hits 2300 RPM with the auto throttle. And then it's going to back it down by 10%, I believe. If I look at climb phase, so we can see here we have options where it'll either go by N1 or RPM, and it figures out which number you put in based on how many digits. So you put in a 4-digit number, it assumes RPM. If you put in a 3-digit number, or if there's a decimal place in the value, or like a 2-digit number, so if you put in a 2-digit number, then it assumes it's an N1. And I can see we're starting to climb a little bit faster, just a little bit. And let me also bring up route manager information here. And actually, while we're here, because I had to make a couple fixes, you'll notice my route manager is all kinds of funky now. So what happens is when it goes to that validate routes method that I had up at the start of the video here, it checks the route manager to see if there's how many waypoints there are. If there's less than 3, then it decides, okay, it's going to make a simplified route for you, judging based on your approach speed, and it sets up a waypoint that'll be roughly where you would want to do your instrument approach, start your instrument approach at. It'll give you 6 minutes to approach the runway, get yourself established, and land. Okay, so I'm going to remove this extra waypoint because that's going to cause problems if I don't remove that. Okay, I believe, yeah. So it's going to be a little while because I put in bad numbers, but we'll get there. So the climb is going to take a while because we're climbing at a guess of the best climb speed, but we're clearly not climbing at the maximum possible rate. And we can actually bump this up even further. I'm going to try 2500 because this is just sad. This plane it's like a bush pilot sort of a plane, so it can get some really good climb rate. Okay, so now I have 3 waypoints in the route manager, so messing with the settings in FGFSCopilot, hitting the start button again, didn't mess with my routes. Okay. Watching the distance here, if this gets down to 12 miles before we reach cruise altitude, we are in trouble. But I'll get to that in a moment. So we are in climb right now. So, yeah, so if the engine RPM is greater than or equal to the set value I put in there, climb rate drops by 10%, else it increases by 25 feet per minute. Pretty simple. Alright, now we're seeing some good numbers here, higher than 500. I'll take that. So clearly I just had a bad number put in for the climb power. But once we reach the top of the climb, we're going to accelerate to the cruise speed. It's going to be 100 knots. So I'm going to pause the recording here. We actually have 2 flights to do, because I'm going to show off a second version of FGFSCopilot as well. And actually, just going to show here, yes, Beaver can climb at a pretty good rate. So we are at 1,200 feet per minute now for the target. You can see that in the VSI here, holding pretty well. And just now hitting full throttle. And we're not at 2,500 RPM. So I knew, okay. But that's okay. So we're going to start losing speed. I think we're close enough to the target altitude that we're going to switch into cruise mode anyway. Please. Please switch to cruise mode. Please switch to cruise mode. Okay, so we overshot a little bit. So I've been testing this a little bit on the new PC I have now, and what I've noticed is FGFSCopilot itself seems to run a little bit slower than before. I had to comment out a line of code, kind of synchronized it with the frame rate of FlightGear, because otherwise it had some issues where it's either running too fast or too slow, and well, right now it seems to be running too slow. Okay, so we are in the cruise phase, and the auto throttle is bouncing us around, so that's fun. Let's look at the code for cruise phase. So, pretty simple, just maintain altitude, heading. Yeah, that's it. So, if we look at the sequential phase finder, if we are in cruise, yes, if we are in the cruise phase, and the waypoint, the distance to the last waypoint is less than or equal to top of descent. If we go into set vars, we can see top of descent is calculated here. Cruise altitude minus touchdown zone elevation over 1,000 times 3. So in this case, it's going to be about 12 miles. Then we will switch. So while we're in cruise phase, once that distance gets to that level, it'll switch to the descent mode. Okay, so for now we're just going to kind of bounce around here because the auto throttle has probably too much proportional gain or something like that. Okay, either that or the altitude hold. Well, whichever. I'm going to pause the recording here, and then I'll get back to you when we're close to the top of the descent. Okay, so in about a minute, we will reach the top of descent. So the descent phase, that's going to do, is you have this variable called VNAV down, and what that is it's literally doing a VNAV calculation from my current altitude to bring me down to the runway at the height of the touchdown zone elevation by the time I reach the runway. And since we're starting using that calculated top of descent, I will maintain a 3-degree descent profile. And I believe since we're in a prop-driven aircraft, it's also going to... It'll probably still maintain cruise speed until we get closer, I think. Or it might start reducing speed right away. I don't remember. We'll find out in a moment. So it should be switching to descent anytime now. Yep, there we go. And it's going to pop up here. Yep, descent. And so we're still holding on to that cruise speed. So let me see what happens here. Descent speed mode. For descent speed mode, we maintain cruise speed in a prop-driven aircraft. Okay? Until we get within a certain distance, I believe. Yeah. I believe that's probably what it is. So descent speed mode. So we've gone into VRF speed mode, but we're still in the descent phase. So let's look at the speed phase finder, speed mode finder, speed mode, yeah. So we're looking for... Yeah, so... And autopilot range organize this and screw it in 2 times. Okay. Alright, so we are within the approach distance. No, we're not. Give me a second here. Because I didn't annotate my stuff very well because I was still very new at writing code. So it's not going to be Mach or cruise. So we have descent for the phase. If it's not empty string and the distance is greater than 2 times the approach distance. The approach distance should be... Okay, alright, so the approach distance is based on your approach speed. So 55 knots approach speed means it's going to be 5.5 miles for the approach. So below 11 nautical miles, which is just 1 mile shy of where we had our top descent, that's where we go into the landing approach speed. We start slowing down so that we can make sure we get configured for landing by the time we reach that IAP. That initial point. Oh no. Oh, okay. We're just ballooning. Hang on. So the autopilot is just being a little bit slow to readjust here to all that extra lift from the flaps. So we're just going to give it a minute. Okay, we are good. Okay. So we are about to oh no, this is awful. This is like a fugoid here. This could be bad news. I might not be able to finish this video. Come on. Oh man, this is bad. This is my first recent test using this aircraft. I thought, you know, let's just record it live and see how it goes. And it's been a little bit of a train wreck from the start. So now we have this fun little fugoid here, and hopefully that corrects itself, because this is supposed to automate my landing as well. And so far I'm not feeling too great about it. So anyway, as we enter a fugoid that may or may not kill us, we're going to look at what the ILS base looks like. So this is our approach base. It's called ILS base because it's just the grandfather in name. We should be reaching... Yep, there it is. Okay. So initially, FGFSCopilot was going to be able to do several different instrument approaches. And, well, I had to abandon that and just stick with ILS only for this to be feasible. And I think we might be intercepting the glide slope. Or attempting to. We are attempting to intercept the glide slope. I think we are in a stall. We're just at the edge of being in a stall. Okay, wonderful. So now we've intercepted the localizer, intercepted the glide slope. Okay, so now while this is happening, we are constantly recalculating the flare height. The flare height is based on my current vertical speed in feet per second. 5 times that number gives us the altitude for when we start the flare. It used to be 4 times, but lately I've had issues with hard landings, so I'm going to try 5 times, 5 seconds, and hope that FGFSCopilot begins the flare at roughly the right time. But the way things are right now, I'm not even sure that's going to happen. But when we reach that phase, it's going to go into wing leveler pitch hold, and then it's going to increase the target pitch by 2.5 degrees from the current pitch. We're also going to go into the flare speed mode, and what that's going to do is that is going to disengage auto throttle. So the current throttle setting will remain active. The throttle lever is going to remain where it was left, and then if my vertical speed is greater than -1 feet per second, it's going to, every time the thread iterates, it's going to reduce the throttle position by 20%. So think about it. You know, it's like how you would land a plane manually. You pull back on the stick to pull the nose up to just slightly above level, so you want those main gear to touch down first. Now we're in a tail dragger, so we don't really want the tail to touch down first. That's going to be bad, but we'll see what happens. And as you do that, you're going to lose airspeed, which should have the effect of reducing lift, but then you're also increasing the angle of attack, which may add on, which will add on more lift, and those effects may or may not cancel out. So yeah. So you may either be able to just gently fly down the runway, or you may have to, but more likely what you'll do manually is you're going to hold that nose up, and you're going to gradually reduce power to bring the airplane, to fly the airplane down to the runway. And that's going to mean maintaining back pressure on the stick, on the yoke, possibly increasing as you go down. I have, I'm hoping the flare, I think the flare will be okay, because all it has to do is hold a certain pitch, and the auto throttle is not going to be a factor. The trick will be making sure, is hoping the flare starts at a moment that makes sense. And while we're here, we might as well talk about the final phase in speed mode, the retard phase and retard speed mode. So what retard speed mode does is that will manually reduce all throttles to 0. And then the retard phase, what that does is, depending on the aircraft, it clears the autopilot settings and deploys the speed brake and spoilers. It also returns the ailerons to neutral position. Once you are rolling, once you have the nose gear rolling, only then does it actually reduce the elevator trim back to the neutral position. And then it applies the brakes to maintain, I think, about 3 knots per second deceleration rate. So it'll actuate the brakes for that. And so you're down to below 40 knots. And then when you're below 40 knots, whoa! It's going to release all the controls. I think we are going to die. I'm pretty confident we are just going to die. I can't die yet because I still need to do another flight. So when I hit this end button, that will also release controls. So, so now, yes, we are flaring. That's a weird flare, but okay, I'll take it. The nose gear, tail dragger. It's a tail dragger, right? Okay. So I had to abort that automated thingamajig. Okay. I just realized that my joystick controls are a bit off of what I had thought they were, so I'm going to pause the recording and fix that in a minute. Alright, well, that landing was awful. Here is what landing should look like with FGFSCopilot, back when everything worked correctly, before FlightGear got several updates. So, same airport again, same runway, different airplane, very stable approach. Look at that. Look at the bottom left. That's just a seat, just the back of my seat behind the joystick. We are at full commitment. Apologies for no audio. The recording glitched out. So going into flare, with the nose up. So a little bit of a rough landing, but not too bad. And then I'm just going to give it some rudder to keep it on the runway, because propeller-driven aircraft, it can wander a little bit. And there you go. That's going to do it for part 1 of this video. Be sure to tune in for part 2 next time, where we explore the super speed version of FGFSCopilot.